Good morning. In our previous session, we have discussed about electrochemical cells, galvanic cells, right? And we have discussed and derived Nernst equation too. So Nernst equation, what is Nernst equation? E is equal to E naught plus 0.0591 by N log concentration of Mn plus by M. This is the Nernst equation for a cell, and E is equal to E naught plus 0.0591 by N log concentration of Mn plus. This is the Nernst equation for a single electrode. So today let us discuss what are reference electrodes and construction and working of your reference electrodes and how to determine the electrode potential of that particular electrode using Nernst equation. So what are reference electrodes? Reference electrodes are the electrodes with reference to which electrode potential of other electrodes can be determined. So reference electrodes are the electrodes with reference to which electrode potential of other electrodes can be determined. There are two types of reference electrodes. They are primary reference electrodes and secondary reference electrodes. Standard hydrogen electrode is the primary reference electrode. So earlier, before the second reference electrodes were invented, we had primary reference electrodes. The electrode potentials or reduction potentials of all the electrodes were determined using primary reference electrode, that is standard hydrogen electrode. The standard hydrogen electrode had few disadvantages. So the electrode potential used to depend upon concentration of hydrogen gas, and also it depends upon temperature and also the pressure. So due to this, the electrode potential of this standard hydrogen electrode used to vary, and it used to be very difficult to maintain 1 atmospheric pressure of this hydrogen gas. So therefore, in order to overcome these disadvantages, we came to secondary reference electrodes. Let us see what are these secondary reference electrodes. Secondary reference electrodes are the electrodes which are having constant and reproducible potential, and these are used to determine the electrode potential of unknown electrodes. So these secondary potential electrodes, the electrode potential of these electrodes have wide range of temperature and pressure. So example for second reference electrodes are standard Calomel electrode, silver chloride electrode, glass electrode, etc. So let us see the construction and working of Calomel electrode. So Calomel electrode, what do you mean by Calomel? So mercurous chloride, the commercial name of mercurous chloride is called as Calomel. Commercial name of mercurous chloride is Calomel. So mercury is placed at the bottom of the, you're going to take a glass tube with a side tube. So we're going to take mercury, we're going to place at the bottom of the glass tube with the side tube. So above this mercury, you're going to place a paste of mercury with mercurous chloride. So then you're going to take a platinum metal, dip in mercury and connect it with a copper wire for external connections. So here the remaining part of glass tube is filled with KCl of known concentration. So as discussed earlier, mercurous chloride is Calomel. So depending upon the electrode with which it is connected with, the Calomel electrode will act either as anode or it will act as cathode. So depending on which the electrode is connected with, the electrode will either act as anode or it will act as cathode. As discussed, the electrode potential of Calomel electrode depends upon concentration of KCl. If you are using 1 normal KCl, electrode potential will be different. If you are using decinormal, it will be different. 0.01, it will be different. How? We'll say it later. Let us assume that the Calomel electrode will act as anode. So then, what is electrode reaction? Then electrode reaction as, the electrode reaction, the Calomel electrode acts as anode, then the mercurous chloride will undergo oxidation to give 2 electrons and 2 Hg, 2 Cl minus. The electrode acts as cathode, 2 Hg, it is reactions are reversed here. So the below reaction is the anodic reaction and the above reaction is the cathodic reaction. So the below reaction, whatever you have written here, that is the anodic reaction. So 2Hg plus 2Cl minus gives Hg2Cl2 plus 2 electrons. That is, the mercury will undergo oxidation to give Hg plus and 2 electrons. So mercury undergoes oxidation. So if the metal acts as cathode, then the above reaction occurs, that is Hg2Cl2 plus 2 electrons gives 2Hg plus 2Cl minus. So these are the electrode reactions. The electrode potential of the Calomel electrode is given by E equals E naught minus 0.0591 log Cl minus. From the above equation, it is evident that the electrode potential of Calomel electrode depends upon concentration of Cl minus. As the concentration of Cl minus varies, the electrode potential also varies. For instance, if you are using 0.1 normal KCl, then the electrode potential will be 0.334 volts. If we are using 1 normal KCl, then the electrode potential will be 0.28 volts. And if you are using saturated KCl, then the Calomel electrode potential will be 0.2422 volts. So as the concentration of KCl changes, the electrode potential of Calomel electrode also will change. So this equation is clearly evident that as the electrode potential, as the concentration of Cl minus changes, electrode potential also will change. Now, so let us see what are the advantages of Calomel electrode when attacked or in general second reference electrode. So it is very simple in construction. The potential is reproducible and stable over a long period. Its electrode potential will not vary with temperature. That is, if you are taking the Calomel electrode, for instance, this is the Calomel electrode, and if you dip, what will happen? So this Calomel electrode will not depend upon the concentration of the species in which it is dipped in, and it can the electrode potential of this Calomel electrode is constant by temperature up to 40 degrees Celsius. So hence it is commonly used as a second reference electrode for potential measurements. So in our potentiometric estimations, usually in electrochemical potentiometric estimations in redox reactions, we are going to use this Calomel electrode as a reference electrode. So even in pH measurement also, we are going to use Calomel electrode as a reference electrode. Of course, we are going to use the glass electrode, but still we are going to use Calomel electrode as the reference electrode. So what are the disadvantages? So this cannot be used in presence of oxidizing agent and reducing agent. The upper limit of the electrode use is pH 8. It needs to be used freshly again and again. So the major application, so these are the disadvantages. The application of this is used to determine potential and pH when combined with platinum and glass electrodes respectively. So it is mainly used to determine endpoints of redox reactions. So this Calomel electrode will be coupled with platinum electrode to determine the endpoint of redox reaction in potentiometric estimations, and the same Calomel electrode will be coupled with glass electrode to determine the pH of the reaction. So pH, so we can determine the pK of the experiment too. So these are the applications. The same experiment, so whatever the both experiments you're going to carry out in your laboratories. Estimation of FAS using K2CR207. So they are going to take Calomel electrode. Okay, Calomel electrode is the Calomel electrode is the reference electrode. We're going to couple with platinum electrode. And the other experiment we're going to conduct in laboratory is determination of pK of given weak acid. So what is pK we'll discuss later. So since pK is related with pH, so pH once again we're going to use which electrodes? Glass electrode and your Calomel electrode. So nowadays, instead of using two electrodes and Calomel electrode and glass electrodes, now we are getting a single electrode, combined Calomel glass electrode. So recent days, instead of using two electrodes, we are going to use two electrodes. Thank you. And next discussion, we'll see the determination of pH using glass electrode and ion selector electrodes. Thank you.